All right, so today we are going to move on to how to solve a logarithmic equation. So yesterday our focus was looking at equations like this, where our variable was in our exponent, so then we use logs to solve it. So to keep along the trend with the whole inverse conversation, today we're doing the opposite. Now what do we do when our variable is in our log? Okay, and we are just going to do this first part today, and then we'll do the rest tomorrow. So breaking this up into 2 days. So a logarithmic equation, let me see if I can practice this really quick, is when the variable is inside of the logarithm. So anytime you see something like this, this, or this. Okay, we did this when we were talking about exponential equations. So I kind of started that off by saying, if I told you that 3 to the x had to be equal to 3 to the 7, what would x have to be? You guys all said 7 super quickly. And then I added a couple adjustments to it, like what would x have to be in this case? But what it boiled down to was if the bases of the exponents are the same, in order for this equation to be true, the exponents themselves had to be the same. So the same is going to be true with logarithms, right? If I told you that log base 2 of x needs to be equal to log base 2 of 50. Well, these two logs have the same base, just like these two exponents have the same base. So in order for these two values to be the same, that means that x and 50 have to have the same value. So x would have to be 50. That's called the property of equality. And so then here, if I just put like variables to it. So if I have an equation that's log base b of m equals log base b of n, then that means that m has to equal n. Okay. So if we look at these three examples, start this one. So this equation I have the natural log of 4x minus 7 equals the natural log of x plus 5. So in order for this equation to be balanced, I'm taking the natural log of two quantities. And so in order for those to be the same, those quantities have to be the same. So 4x minus 7 has to equal x plus 5, or else those natural logs will not be equivalent. And so when I go to solve for x, let's move my x over first. So that would be 3x minus 7 equals 5. Add the 7 over. And that means that x has to be 4. Now, the one thing that we always have to be aware of when we're solving these logarithmic equations that we did not have to worry about with exponential is that one of the things that we have been talking about is that you cannot take the log of a negative number. Right? Because there is nothing that I can raise 5 to get negative 125. So you almost want to maybe add that in here. You always need to make sure you check for negatives. So you need to double check to make sure that whatever you get for x doesn't make this quantity negative. Okay, so 16 minus 7 is going to be 9. That's going to be 9. Both of those are positive. They're equal. So I know my equation is good to go. All right, now in number 2, I've got log base 3 of x squared minus 14 equals log base 3 of 5x. So I'm taking log base 3 of two quantities. So in order for those two quantities to end up equaling out, that means that they have to be the same, or else this equation would not be true. So I'm going to set x squared minus 14 equal to 5x. And because I see this x squared, that tells me that I'm probably going to have to factor unless something cancels out. So I'm going to start by setting my equation equal to 0, moving that 5x over here. So x squared minus 5x minus 14 equals 0. And then that's going to break down to x minus 7 and x plus 2. Right, I'm looking for two values that multiply to negative 14 and add to negative 5. So then after I set each factor equal to 0, I get x to be 7 or negative 2. Okay. Now, remember, it's okay. Well, actually, I shouldn't say remember. I don't think we've talked about this yet, but it's okay for x to be negative. Your variable can be negative as long as it doesn't make the quantity in your logarithm negative. So for example, now I need to check that both of these values are true. So you always go back up to your original equation. Well, 7 squared minus 14, 49 minus 14, it's going to give me 35. 5 times 7 is 35. So I know that that solution works. When I plug in negative 2, remember when you square a negative, so you need to make sure you put parentheses around it, it's positive. So 2 squared minus 14, I'm plugging that in right here, I get negative 10. You cannot raise 3 to a power to get negative 10, right? Because we're thinking about that as an exponent. So that means that this solution does not make this equation true because you cannot take the log of a negative number. And so that means that 7 is my only solution here. All right, and so now this last one here, now we're pulling in what we did in 7.5. Just like any equation you're solving, your goal, so if I were to give you an equation like this, like 2x minus 3 times x minus 10 equals 20. I'm not going to go through and actually solve it. But if I were to give you this equation, our goal would be to use all the properties of algebra to get down to negative x equals something. I don't know if it would be what? Negative 10, I think, if I'm doing my mental math correctly. So we're trying to get one variable component on the left and one constant on the right in order for us to solve. So it's kind of the same thing here. Before we can set anything equal to each other, we need to combine like terms over here. So we have to remember then, okay, well, what do I do to put subtraction back together? What property is that? And so we have to remember that when we are subtracting, we divide. Think about the properties of exponents. Subtraction goes with division. Addition goes with multiplication. Raising to a power goes with multiplication. And so I'm going to take log base 6 of x minus 3 over 4 equals log base 6 of x plus 2. Okay, so now I've got this one logarithm on the left and one logarithm on the right. I'm taking log base 6 of both of those quantities, so that means that these two quantities have to have the same value, or else this equation doesn't work. So I'll set x minus 3 over 4 equal to x plus 2. We want to clear the fraction over here. So x minus 3 is being divided by 4. So now I'm going to multiply both sides by 4. We have to remember then we're multiplying the whole quantity by 4. So this is going to give me x minus 3 equals 4x plus 8. And then I'm going to go ahead, let's move, I'll do this now in one step. So I'm going to move the 4x over and add the 3 over. And then when I divide both sides by -3, I get that x equals -11/3. And so I have to go back and check, make sure that value doesn't make any of my logs negative. So when I go and look at this, I see that it's x minus 3. So if I put -11/3 in here and I'm subtracting 3 more from it, it's going to continue to be negative. -11/3 minus 3 gives me -6 2/3. Well, that doesn't work. So after all that work, it turns out that this has no solution. Okay, there is no value of x that can make these two logs equal. Well, I guess 3. That will make this equal. Okay. So you always plug it back into your original equation. All right. And so your homework tonight, if you look in your packet, the 7.7 homework, oops, I forgot one, is to do numbers 1, 2, 3, oh, not 3, sorry, 4, 6, and 8. Double check on the back, make sure there's none over there. Yep. And then your homework tomorrow will be to finish these other ones. As always, email me with questions or hop on Canvas conferences today.